Hello students, welcome to the class of teacher Meenal Pereira. Let's begin this video by first studying how the force acts on a current carrying conductor in a magnetic field. And to study this, first the experimental setup, as you can see from the diagram. You need a flexible copper wire, a stand, electrical cell, a horseshoe magnet with a strong magnetic field. So these are your materials. Coming to the procedure, using the stand, fix the copper wire so that it passes through the poles of the horseshoe magnet as shown in the figure. Okay, so as you can see in this diagram, a wire is passed through this horseshoe magnet. And then we have connected the circuit here as shown in the diagram. Now, once the plug key is closed and the current starts moving through the current, what do you observe? We observe that whenever a current is not flowing through the wire, it remains in straight position, that is position A. But when the current flows from top to bottom, the wire bends and comes into position C. Okay, so look children, the first case, when there is no current flowing through the circuit, the wire is straight, position A. But as the current starts flowing through the circuit from top to bottom, that is from upward to downward direction, we see that the wire bends and comes to position C, which is shown by a dotted line. Next, what happens if the current direction is reversed? That is, it flows from bottom to the top end. Then what is happened? The wire bends but comes in the position B. Okay, so first when the current is flowing from top to bottom, it is going to C, and when the current flows from bottom to top, it is going towards, or it is taking the position B. So this means that the direction of the force on the wire is perpendicular to both the magnetic field and the direction of the current. Okay, so the force that is acting on these wire, okay, that direction is perpendicular to magnetic field as well as the direction of the current, because when the electricity or when the current flows, it exerts a force and thus the force acts on a conductor into the magnetic field. So this wire is a current carrying conductor which is in this horseshoe, that is magnetic field. Okay, so I hope you are clear. Let's study this in details. Now, in this experiment, it is noted that whenever current flows through a conductor in the presence of magnetic field, a force is exerted on the conductor. So as I told you, whenever the current flows through a conductor which is present in the magnetic field, it experiences a force. If the direction of the current is reverse, the direction of the force also gets reversed. This point you have to remember very well children, because next we will be studying electric motor. Okay, so that time you have to remember that when the direction of the current is reversed, the direction of the force also gets reversed and vice versa. If the magnet is kept reverse, that is, its south pole is brought at the position of its north pole, and its north pole is brought at the position of south pole. Then what will happen? Now first we saw the current flowing from top to bottom and then from bottom to top. Now we will study about the magnet, the poles of the magnet. That is, we are interchanging the north pole and the south pole. Then what will happen is, when the magnet is kept reverse, the direction of the force also get reversed and the wire is bent in the opposite direction. Okay, so this is the first case. Okay, when the wire is straight, the current flowing through I, that is the current flowing through, is 0. Now here we see the bending of the wire towards, or this is the wire and now it is bended to B, when we see that the current is moving in the upward direction. And when the current is moving in the downward direction, we see the bending of the wire to C. Now what is this cross shown inside, children? This is the charge. Okay, so we all know that a conducting wire, it has, or the electrons that are present that are responsible to carry the charge. Okay, so this charge is shown by this plus sign. Okay, so this is the basically the diagrammatic representation. What you have to remember is, when the magnet is kept reverse, the direction of the force also get reverse and the wire bends in the opposite direction. So what we can study from the above experiment, it clearly shows us that a force is exerted on the current carrying conductor. Okay, and from where the force is coming? The force is because of the magnet, the magnetic field. The direction of this force depends on both the direction of the current and the direction of the magnetic field. So in short, you can say that force, current and magnetic field, these three are related to each other. Okay, when one is affected, the other two are also getting affected. Okay, now this is very well explained by Fleming's left hand rule. Now let's study what is this left hand rule. In the above experiment, we consider the direction of the electric current and the direction of the magnetic field. And what we found, that the direction of the force exerted is perpendicular to both. Now very often we heard the word direction, direction, direction. So direction of these three we are taking into consideration. Now this is very well explained with the help of a simple rule. And this rule is called Fleming's left hand rule. Now what is this rule is? According to this rule, the left hand thumb. So take your left hand thumb, the index finger and the middle finger are stretched so as to be perpendicular to each other. Okay, now try stretching and it has to be perpendicular to each other. See, look in the diagram how it is shown. Okay, so like a gun you have to hold this. If the index finger is in the direction of magnetic field, this is the index finger. The index finger is in the direction of magnetic field. The middle finger is in the direction of the current. This is the middle finger which is in the direction of the current. Then the direction of thumb is the direction of the force on the conductor. Okay, so simply the index finger shows you the direction of magnetic field. The middle finger shows you the direction of the current. Then the thumb will point to the direction of the force on the conductor. Okay, so arrow, with the help of arrow, we can show it this way. Okay, now this principle very well we are using in electric motor. Okay, what is an electric motor? It is a device changing electrical energy into mechanical energy. And that is known as electric motor. So, changing electric energy into mechanical energy that enables us to do various kind of work. Now, around us in our day-to-day life, an electric motor is a boon. We see so many things on which we use electric motor. It is used in fans, refrigerators, mixers, washing machines, computer, pumps. Almost all the electrical gadgets we use this electric motor. Okay, so now we will study how does this motor works. Okay, let's study how it works. Okay, now let's study about the construction of electric motor. Okay, now this electric motor consists of a rectangular loop made up of copper wire having resistive coating. In the diagram, it is shown by ABCD and this is also called as armature. Now this is made up of copper. Now this copper wire is placed between the north pole and south pole of a magnet such as a horseshoe magnet. So diagram we can see two poles of the magnet, north and south, and the coil is placed in such a way that its branches AB and CD are perpendicular to the direction of the magnetic field. So as you can see from the diagram, the branches AB and CD are perpendicular to magnetic field. Okay, so this is the direction of the magnetic field, and AB and CD. So this is the direction of the magnetic field and AB. So this is perpendicular to each other. Now next, the two ends of the copper wire are connected to two halves, that is P and Q, as shown in the diagram. This is called as split ring commutator. Okay, so you can see in the diagram the loop P and Q these are the split ring commutator. The two halves of the ring have resistive coating on their inner surface and are tightly fitted on the axle. Okay, so this is the diagram where you can see the axle. So this split ring are fitted on the axle. Next, two halves of the ring, as I told you, it has a resistive coating. Halves of the split ring X and or P and Q have their outer conducting surface in contact with the two stationary brushes X and Y. So as you can see in the diagram, the two ends P and Q are in contact with two stationary carbon brushes X and Y. So here we can see these two carbon brushes X and Y which are in contact with the split ring commutator P and Q. So this is about the construction. Now let's see what is the working or how basically this motor is work. Okay, now to work, of course, electric current is required to pass through, so it is connected to a cell. So as you can see from the diagram, it is connected to a cell and the cell is going to supply electric current. Now when the circuit is completed as shown in the figure, the current flows in the branch AB of the loop from A to B through the brush X and Y. Okay, so as you can see from the diagram, we can see the current flowing through the branch A to B through the brush X and C to D through the brush Y. Now let's see about the direction or how we can notify the direction. Now Fleming's left hand rule we have already studied. According to this is the motion of the force, this is the direction of the motion of the force, this is the direction of magnetic field, and this is the direction of induced current. Okay, so what we can conclude from this is a force is exerted on branch AB and pushes it downwards. Okay, so diagram you can see that a force is exerted on branch AB and that branch AB is pushed downward, and the current in the CD branch is in the opposite direction to that of AB branch, and therefore in CD the current is exerted in the upward direction. Okay, so you can see from the diagram the direction with the blue arrows, you can see the direction of the force. So you can very clearly see that in one side it is going up, so other side it is going down, or vice versa. Both is going in the opposite direction. So the loop and the axle starts rotating in the anti-clockwise direction. So they are moving in anti-clockwise direction. Now this is for first half. Now what is happening after first half is, after the half rotation, P comes in contact with X and Q comes with the brush Y. Okay, so now it is changed. So the current reverse the path and start flowing in the direction DCBA now. Okay, so after half rotation, the current reverse or changes its path and now starts flowing in the opposite direction, that is DCBA, that is in this direction. Okay, so what happens is the reverse of the current also reverse the direction of the force. Okay, so as the current is reversed, the direction of force is also reversed. This also I explained you in previously that when the direction of the force changes, the direction of current changes. When the direction of current changes, the direction of force also changes. Okay, so now what is happening now is the arm AB of the coil that was pushed earlier downwards now pushed up. Okay, so the coil or the arm is now pushed, AB pushed upwards and the arm CD pushed in the downward direction. So the coil and the axle rotate half a turn more in the same direction. Okay, so from diagram you can see that now branch AB is in the upward direction and branch CD is in the downward direction. And the coil and the axle rotates in the same direction, that is in the anti-clockwise direction. Okay, so thus the current in the loop reverses after every half rotation and the loop and the axle continue to rotate in the anti-clockwise direction. So it keeps on rotating in the anti-clockwise direction. So almost all the commercial motors run on the same principle, but sometimes some modifications are done for their constructions that you will study later. Okay, now children, one more thing you have to study is what are the uses of these carbon brushes. We can see here in the diagram the two carbon brushes X and Y. So what is the use of that is these brushes are used to press the split ring. We can see the two split ring P and Q in this. So to press this we need these brushes X and Y. So what will happen after pressing? It will bring the contact between the split ring and the brush and it will result into the flow of current. Okay, so this is as if when the brushes press the split ring, the connection becomes one and the current starts flowing through the circuit. Okay, so thus we can see that. So this is the construction and working of electric motor and continuous flow of current we get as the coil keeps on moving or rotating in the magnetic field. Okay, so I hope you all are clear about the construction and working of the motor. Very important. Please read and listen it carefully. Thank you very much. Take care.